In this question, we want to determine the point on the y-axis equidistant from this point and this point. We have the answer given to us here. Now let's see how we got it. Well, we know that a point on the y-axis has to have the coordinates 0, r, 0 for some scalar r. Now, because the distance from P to R equals the distance from Q to R, we can say that the magnitude of vector PR equals the magnitude of vector QR. And we can then set up our distance formulas. A little thing I'm noticing about this particular solution is I actually set it up backwards. I should be saying RP is equal to RQ, instead of PR is equal to QR. Now, there's no real difference in reality. It's just that the way I set up these distance formulas, I was setting it up with the with the P minus the R. So I was setting it up more as if I was doing it this way than as if I was doing it this way. But anyways, hopefully you see that what I've done here is I've just said the magnitude of the vector RP is the P coordinate minus the R coordinate each time. 2 minus 0, quantity squared, plus 3 minus R, quantity squared, plus 9 minus 0, quantity squared, square rooted. And then the magnitude of the vector RQ is the Q coordinates minus the R coordinates each time. So negative 4 minus 0, quantity squared, plus 7 minus R, quantity squared, plus 11 minus 0, quantity squared. So this is 4 plus 9 minus 6r plus r squared plus 81 under a square root, and that equals 16 plus 49 minus 14r plus r squared plus 121 under a square root. If I square both sides and collect like terms, I get r squared minus 6r plus 94 equals r squared minus 14r plus 186. These r squared terms nicely cancel out, and we're left with a linear. 8r equals 92, so r is 92 over 8, meaning it's 23 over 2. So the point is 0, 23 over 2, 0. And if we were to take this point and get the distance from P to that point and from Q to that point, we would see that those answers are equal.